Dear students, Namaste. I am Chandan sir from Allen Career Institute at Powai. In today's session, we will discuss a previously asked JEE advanced question, that is from P block. So, let us see the question. Upon heating potassium chlorate, that is KClO3, this is the potassium chlorate we have, in presence of catalytic amount of MnO2, that is manganese dioxides. So, for simple explanation of that, already I have taken a flow chart. So, this is our potassium chlorate, that is KClO3, that is white crystalline powder, and this is manganese dioxide MnO2. MnO2 is blackish brown powder, okay, and here it is acting as a catalyst. Dear students, we know that catalyst increases the rate of reaction and decreases the activation energy. So, it will increase the rate of reactions basically here, and further let us see, when we are heating that, we are getting a gas W. So, when you are heating potassium chlorate in presence of manganese dioxide, we are getting a W gas. Okay. So, if you recall the reactions of heating of potassium chlorate, you know that the product will be KCl, that is already here, that is again a white crystalline powder, and oxygen gas. This is the oxygen gas which will be produced in this reaction. Okay. If you write the balanced reaction, it will be 3/2 O2. Okay. Now, further, the excess amount of W reacts with white phosphorus. Okay. So, first let us see, we have started from potassium chlorate, okay. We have heated it in the presence of manganese dioxide, which is the catalyst here, and the product we are getting is potassium chloride and oxygen gas. So, according to this paragraph, you see this W gas is oxygen gas. Okay. Let us go further. Excess amount of W reacts with white phosphorus to give X. So, this is white phosphorus in this flow chart, white phosphorus, and we are treating it with excess of oxygen gas. So, from the reactions of white phosphorus with oxygen, you must remember that if we have limited supply of oxygen, just like air, the major product will be P4O6, but if it is excess of oxygen, we will be getting P4O10. So, that is the combustion reaction of white phosphorus, that is the combustion reaction, and here the fumes that we are getting, that is white dense fumes, that is basically P4O10. Okay. So, let us see once again, this is the starting material potassium chlorate. First it is heated to give you KCl and oxygen gas, that is your W gas. Further, it is treated with white phosphorus. Here this is the picture of white phosphorus. This is translucent waxy solid and it's highly poisonous. Okay. And when it comes in contact with the air also, it catch fire. Okay. So, when you will be treating with excess of oxygen that is obtained on heating this potassium chlorate, we will be getting P4O10, that is our final product. So, let us see, P4O10 must be the compound X and this oxygen gas must be W. Okay. After that, the reaction of X with pure nitric acid gives Y and G. Okay. So, when you react this P4O10 with nitric acid, okay, pure nitric acid, this P4O10 is a good dehydrating agent, Okay. So, its tendency is just to remove the water and make the anhydride of nitric acid, and you know very well in the oxides of nitrogen, in that I have explained that N2O5, where the nitrogen has maximum oxidation state, most acidic oxides of nitrogen, basically it is the anhydride of nitric acid. So, you will get one of the product as N2O5. that is the most acidic oxide of nitrogen, and other product will be getting metaphosphoric acid, that is HPO3. So, this is the overall reaction that is involved in this. So, let us see here, your W is the oxygen gas which is obtained by heating the potassium chlorate. After that, this P4O10 is the compound X which had been obtained by heating the white phosphorus in excess of oxygen. Okay. After that, N2O5, that is the product obtained when we are treating nitric acid with the P4O10. So, basically P4O10, a powerful dehydrating agent, is removing water and forming anhydride of nitric acid, that is N2O5. Okay. And the last one, that will be our Y. Okay. And the last one is this product, that is metaphosphoric acid, that is G. Now, we will come to the questions now. The first question is, W and X are respectively, W and X. If we see, the W is the product obtained in the first reaction itself, which is an oxygen gas. So, if you see the first option, this is ozone. So, you can eliminate this option. Fourth option also, it is ozone. So, you can also eliminate this option. Now, we have only two options left, oxygen and here also oxygen. Now, we will go to the next product, that is X. If you see, X is P4O10, okay, that is tetraphosphorus decoxide. So, you can eliminate the option second also, because in option second you can see here it is P4O6. Okay. So, we have already eliminated option A, option B and D. So, the correct answer we can see that the X is P4O10. So, it will be option C. I have a simple video also that I can play right here, and that will explain how the white phosphorus will be reacting with the excess of oxygen to produce white dense fumes of P4O10. So, let us see the video. Here in this container we have white phosphorus kept in water. Why we are keeping this white phosphorus in water? Because it is highly reactive. When it come in contact with the air, it will react, it will catch fire. So, in order to protect it from the contact of air, we are keeping in water. Okay. So, now let us see, this is the white phosphorus here. When it is brought to the air, it started igniting spontaneously. You can see it is catching fire and white fumes are getting evolved. Okay. These white fumes are the oxides of phosphorus, mainly P4O6 and P4O10. And when we will be ignite this white phosphorus, okay, with the burner, you can see, yeah, it will explode. It is a explosive reaction we can see here, and it is producing the oxides of phosphorus, mainly P4O6 and P4O10. So, white phosphorus in presence of pure oxygen, if the oxygen content is very high, mainly it will be producing P4O10, and if it is air, we know that air oxygen content is only 21%. Okay. So, in that case we will be getting mainly P4O6. Both are dense white fumes, okay, and they are also used as a smoke screen. Okay. So, we will now go to the next question of this paragraph. Y and G are respectively. Okay. So, let us see, Y is N2O5. So, if you see the options, option A is N2O3, which is a blue liquid, basically oxides of nitrogen. N2O4 is colorless gas, okay, which is dimer of nitrogen dioxide. So, this is also eliminated. If you see D option N2O4, again wrong. So, only left is option B. So, option B will be the correct answer for the second question, that is N2O5, that is anhydride of nitric acid, and metaphosphoric acid, that is HPO3. So, dear students, in today's session we have discussed the reactivity of white phosphorus, like it is very reactive, it is very poisonous, okay, and we have seen the reactivity with excess of oxygen forming T4O10. We have also studied about the dissociation of potassium chlorate, like it gives KCl and oxygen gas, where the catalyst is manganese dioxide, and already I explained this catalyst that is blackish brown is basically increasing the rate of reaction. Okay. So, dear students, that is all for the today's session. In the next I also will be discussing previous year JEE questions. Thank you.